Whoa. That was live. I'm awake now. And I'm also on the board of Knowledge Graphs for Social Good. So if you want to talk about any of those things afterward, come find me afterward, and we've got plenty of time to chat. So let's talk about city resilience with the United Nations. We've had a fun year this year, right? And so how many of you, either personally or know somebody that's been impacted by severe weather, climate change, or a natural disaster? This is a quick show of hands. All right, pretty much everyone. Thank you for hearing me there. As these incidents become more and more common, we're going to have to start thinking about how are we actually going to mitigate the impacts of these kinds of natural disasters, right? And so you can see that whether that's the fires in California, the unprecedented heat wave in Europe, the floods that literally happened here in Vegas just a little while ago. And I have to apologize to my colleague Zoe in the front seat, because this year we also had the first named heat wave, and for some reason they decided to name it Zoe. So I don't know why I didn't pick this name, but yes, we did have our first official heat wave. And so actually the World Bank predicts every single year that over 26 million people are going to be displaced or pushed into poverty just because of natural disasters alone, right? And that's a lot. And how, there's a lot of different organizations that kind of combat climate change and help with city resilience, but the two that I'm going to talk about today are with the United Nations. And there's kind of two different groups. So if you think about the UN, it's obviously a massive organization, but just like any technology project that we have in the private sector also, there's kind of the business side and the technology side. So the business side is UN Habitat. They're really focused on urban planning. They're the city experts that go and help different mayors create policies, et cetera. And then you have the UN Secretariat, which is really kind of the technology team, and they're really looking at how to apply cutting-edge technology like AI or knowledge graphs or whatever it is to actually help people out in the field. And so they've been thinking about this problem for a long time. And in particular, they have an established methodology for risk assessment and looking at vulnerabilities and how to help city officials mitigate the impacts of things like natural disasters. So let's pretend that you and I were all these people in front row. We're the Tiger team, and we're going to go help Vegas create better policies for flash floods. So the first thing they do is they would go in and understand the overall context of Vegas. What are the buildings there? What are the structures? How old are the buildings? When were they constructed? What are the past incidents that have happened in Vegas, right? And then we would kind of work together with those city officials to identify risks and vulnerabilities using the data that we've collected. Let's say it's like, I don't know, census information, building code data, whatever you can possibly find working with city officials. And then finally, the last step that we would do is say, okay, now what do I need to recommend the mayor of Las Vegas or whoever it is? How can I tell them if they have $15 million in budget, where to best allocate that money to mitigate the impacts of a flash flood? Is it, maybe you need to put more drainage systems and invest $10 million in this section of the city, right? Something like this. So that's really the ultimate kind of question that they're trying to answer. And while they have this established methodology, like a lot of amazing things, the really skilled talent of urban planners, they're really scarce. There's not a lot of them out there. And also it's a very manual process, right? So if, front row seat and we have to go fly to every city in the world, how long is that really going to take? And can we help everybody with the different problems they have? And I think it's pretty clear the answer is no. So one of our main customers here is Lambert at the UN, and he was saying that it takes up to several months, all the way to like 2 years to do one vulnerability assessment for a city and to create some policy recommendations. I mean, it's really hard work. But he said if you think about it, they're doing 1 to 2 cities a year with this Tiger team, and there's 40,000 cities in the world. So you can quickly see, without going into too much detail, that there's a scalability problem here, right? And so we started talking about, what are different technologies, and they kind of already, just out of curiosity, how many of you have heard of a knowledge graph or graphs in general? All right, okay, cool. That's actually a surprising amount. So they had heard about knowledge graph technology, but they were like, I don't know, maybe this is a good way to use it, but I think there's something here. And so I hope through this kind of journey that maybe we can also think about how it applies to you. But let's talk about their goals. So they had a certain set of business goals, and they also had a certain set of technology criteria. So there are 2 business goals that they specifically said. They said, hey, I want to have an investigative knowledge system where I can kind of go in and do some exploratory analysis. I have some standard questions like what's the population density in Las Vegas around the MGM. But maybe I also have, hey, what's the average rainfall in Vegas, this other area? So that's like one bucket of needs they had on the business side. The second is really cool around simulation. So, now that I have this base information about a city, if I know the average rainfall, if I know the topology, can I, in the same tool, do simulation also? So, if a flash flood happened at the MGM, who else is going to be impacted? What if a tornado were to hit somewhere in the middle of town? So those are the 2 things that they were really wanting to understand from kind of the business side. On the technology side, they had some kind of interesting requirements that I don't think are unique to just like the United Nations on this use case, right? I think it's really common especially for more cutting edge technologies where, you want domain experts to be able to use your system, right? An urban planner shouldn't have to go to IT or shouldn't have learn Java tomorrow, right? To be able to go use a tool to help them in their day job, right? So they wanted a tool where they could also kind of leverage their own expertise, but not necessarily wait 2 to 3 months every time they wanted like a feature added, right? Or to be able to run the simulation or analysis, which a lot of tools today are proprietary, and that does require that. The second thing that they were really interested in is, okay, well, if I'm doing a vulnerability assessment, I have a lot of different data types. So you might use everything from census information to survey data or other types of unstructured and structured data that you need to pull together to understand a city, right? And because it's the last session of the day, I'm also going to pick on people. So what sorts of information might you pull from to understand Las Vegas? Like what kind of data would you think about looking at? Anymore? Population, great. Census data. Topology, yeah, perfect. The elevation in the back.
Maximum rainfall rates, since those are much more important than total rainfall.
Maximum rainfall rate, yeah, like how bad can it get? Right, okay, one more. Traffic, great, yeah, exactly. So if you know that there's a lot of congestion in a certain area, you may know that, okay, well, if I'm developing a policy, I want to reroute them, a different way, or maybe I need to create other mechanisms for people to exit. So great, thank you. The third kind of criteria that they had was also around, hey, if I want to make this thing really scalable, I think the whole community needs to be able to contribute to this. So how do we think about open source? And that's always tricky, so. Okay, so we were talking about and thinking like, okay, well, how can I really apply this to this use case? Does it even make sense? So one of the criteria that they had when we talked about was doing analysis and simulation in the same tool. So they didn't want to go buy something to do the ad hoc query and then another tool to do simulation. And they didn't want to have to do that in like 6 different languages. Like maybe I need Excel and SQL here, but then I also need like C++ and Java over there. Like that didn't make sense for them. And so while they were thinking, hey, knowledge graphs could be really good for this, the challenge was, before we had started our discussions, that it's they don't have a lot of resources to build their own infrastructure, right? And it's not trivial to create a knowledge graph today, right? It takes a lot of engineering work, and so we're like, hey, but we can help with that. So that's challenge number one. The second requirement that I just mentioned was that they have data from a lot of different sources, and they knew that knowledge graphs are good for this, and they knew that it was really good because there's also, there's other precedent for this. All right, so there's an organization called Forensic Architecture. They're super cool, check them out. But they do smaller recreations of disasters, specifically for things like bombings and fires, et cetera. But again, this is a proprietary tool that they wouldn't be able to use their own data on, or they'd have to pay a license in perpetuity, basically, and they couldn't add any other features. So that was challenge number two. But they knew that knowledge graphs were good at combining these different data sources. And then the third one, so I'm curious, any math nerds in here? Mathy nerds? Oh, okay, I see you. Kudos. So fellow mathy nerd here, they were like, okay, well, we also wanted to do open source, and we want to do this simulation thing, but man, you really need to, do you actually have to know C++ to use this thing? But the cool thing is that actually you can do what's called this probabilistic programming, which sounds terribly intimidating until I show it to you, and it pretty much reads like English. But it sounds intimidating, but it's really not. But it can be run over a relational knowledge graph, which is also really cool. And I'll show you exactly what that means and how that looks. So in summary, when we were talking about how to evaluate a knowledge graph for this use case, they're like, okay, well, we know that knowledge graphs are really good at understanding complex data, lots of different relationships in data, and it would really help us do that what-if analysis in a single tool while giving us automation and scale. But the cool thing that I want to highlight is, okay, so why a relational knowledge graph? Okay, well, there's a few reasons why. One is that a relational knowledge graph, you can also do what my colleague Amy Hodler, she wrote the book on graph algorithms, she's really cool. You have to check out the book if you have it. She coined this term math in a graph. And that's one key reason for using relational knowledge graphs is you can do the simulation within the actual graph, and that's pretty innovative. But it's also a lot more easy for domain experts to build on top of and also execute and understand. And I'm going to show you exactly why. Okay. So we augmented kind of the existing city, I showed you that methodology that they have, and so all we did was augment that 5-step process with a little bit of tooling at each step. So the first step was, hey, let's sit with the domain experts and kind of look at how do you think about a natural disaster? What are the concepts involved if you're thinking about a city and how a natural disaster impacts it? So earlier you said traffic, I heard topology, et cetera. So those are all different concepts involved, okay? The second is how do we think about codifying expert knowledge in the same system that maybe you would do in SQL or programming, et cetera. And then how do you also then kind of execute on that knowledge? And I'll show you exactly what that means. So without going too much in the details, is just a simple example of the actual thing that we're going to open source. But I think it's sort of, once I start talking about this, I think it'll be pretty self-explanatory in terms of, okay, in the top right, you have a city, right? It's a city at the top right. And that could be Las Vegas. A value of city could be Las Vegas. Associated to the city, you have what's called an urban element, right? And if you think about urban elements, what are those? Streets, drainage systems, hospitals, airports, right? And those are impacted by the box in red, which is a shock. And a shock is a natural disaster, right? So I think you can kind of start to see, even business people or domain experts, they can create something, a diagram like this, right? I don't know. What do you guys think? Raise of hands if you think a domain expert can kind of get the gist and read this. Yeah, it's pretty, once you kind of talk through it initially, I think it's pretty accessible. And so what if I then told you that this diagram is actually executable, right? And your infrastructure, your database, can actually read it in the same way that you read this graph. And so that's really what the power of what we did is that, hey, any domain expert can kind of read this mapping and then be able to execute queries on it. So for example, like, what are the biggest impacts? What infrastructure is impacted by shocks? But also, most importantly, what are the second and third level, like the domino effect of a natural disaster? So that was like the risk investigation side. The other way to look at a city is spatially, right? So a city has like a hub, like if you think of airports, there's usually like a downtown and a center, and then there's buildings around it, right? And then you have suburbs, et cetera. Well, if you were to take a look at mapping that out, it kind of looks graphy, right? Like it's all connected, and you see different hubs and spokes. And you can think of the city's roads, et cetera, as part of a knowledge graph. And so what's really cool about what we were able to do is in the same system, just like how you saw that business concept kind of mapping, you can also run simulations within the same infrastructure. All right, and I'm not going to go into too much detail on these because I want to be cognizant of time, but basically how you do that simulation is actually also quite business accessible, right? You would describe, let's say, a city has houses. Houses are made of concrete, sometimes they're made of wood, and if you have a fire, which one is more likely to spread the fire? The wood, right? Yeah, thanks. And I'm almost to the end here. And then for the simulation, I just want to show you like a cool mapping nerd joke because I see some of us in here. And so the stuff for simulation is, we also incorporated satellite imagery. So think about Google Maps. You overlay the topology, and then we map that elevation on there, and then you can run through what's called fractal interpolation. You can run the simulation and basically do color coding of where the flooding will be the most severe, and in this case in Amman, Jordan. So they don't need to know any of the engineering. They can see just the color-coded map. Also, by the way, a fun fact, kale is a fractal in the natural world, so kind of looks like kale. Pretty joke. All right, so let's move on to the end. So I just want to conclude with that thought. I hope this helped you kind of think about how you might also leverage something like knowledge graph technologies. For them, we're really committed to helping them improve city resilience by providing these tools open source as well, and so that they can really scale their ability to understand risk, vulnerabilities, and also prioritize their budgets. So if you have any questions, that's really the end of the presentation. Come find us at the Women in Data reception. We're going to be, I think, in 356, and I'm happy to take questions on any of these UN or Women in Data as well. Thank you so much.